I'm Kat Scott. I'm a developer advocate. I work for Open Robotics. So Open Robotics is actually an umbrella organization for two other organizations. One is the Open Source Robotics Foundation, or OSRF, and the other one is the Open Source Robotics Alliance. And generally what we do is we support the development, distribution, and adoption of open source software for use in robotics research, education, and product development. So underneath this umbrella organization, we actually have five main open source projects. The one that you've probably heard of or may have heard of is ROS, or Robot Operating System. We have four others, though. One is Gazebo. Gazebo is a robotics simulator. It's one of, I don't know, half a dozen different open source robotics simulators that's out there in the world. A fairly new one for us is OpenRMF. OpenRMF is basically a framework for handling multi-robot fleet interactions along with infrastructure. If you've ever been to Singapore and seen the robots in the Changi airport, those are all controlled by OpenRMF. We also have ROS Controls. ROS Controls is basically a subset of ROS that's focused on real-time control systems. And then the last one is our infrastructure, which it sounds trivial, but we serve close to 1 billion ROS packages every year. We're responsible for keeping a lot of people's robots secure and up to date, so it's a non-trivial part of what we do. So let's talk about ROS. If you're not familiar with ROS, ROS is probably the oldest, most widely used robotics framework in the world. Roughly on the inside, what you'll find is ROS has tools for managing the movement of data through a robotic system. It's got tools to make it really easy to create the small programs from which you compose larger robotic systems. We've got a bunch of tools that you can use to build your robot, to introspect what the data's doing, to log data, to visualize what your robot's doing, to parse a 3D model, and then do your transforms between different parts of the robot. And then we also basically have an ecosystem, much like Python. We have packages that you can import into your ROS system that give you certain capabilities like, running a LiDAR, processing that LiDAR to do SLAM, that sort of thing. So just to give you a brief sense of how big this project is, these are old numbers. These are from 6 months ago. We have about, just for our servers, which our servers do not cover the entire ROS community. People use Docker containers. People have mirrors. We have about 1.3 million monthly users of our ROS packages. We're looking at about 1 billion packages downloaded annually. I just pulled the numbers for May. We're actually looking to double that this year again. In terms of companies, since we're open source, we don't do any of this sort of telemetry that, say, a company or a startup would do. So we have to go have conversations, look at people's recruiting, that kind of thing. I can tell you that I've personally talked to or seen close to 1,700 companies that use ROS. It is a giant part of the robotics industry. But if you want to look at it in terms of people, right, we can basically throw a ROS developer conference anywhere in the world, and a few hundred people to a few thousand people will show up. On the top left is ROSCon Global in Singapore of last year. This year, I think we're aiming to have about 12 regional ROS developers conferences, everywhere from Italy, Turkey, Japan, China, India, Spain, Germany. Basically all over the world. You can find ROS developers on every continent. So I want to talk about our AI strategy and how we think about it. These sort of break down into silos, if you want to think about it that way. The first one is the one that everyone thinks of is these sort of VLA models or the deep models. But we also think about it in terms of both how do we use AI to improve the software that is in our open source project and also accelerate sort of our development speed. Open source has always been fairly agile, and we're looking to use AI to make things more improve quickly. Then we're also looking to how we can use AI to help people take the code that we already have and make building their end user applications a lot easier and quicker. And really what we think about when we're thinking about all these things is how can we use what exists in ROS already as sort of the data backbone for AI. So let's talk about how a robotic system is put together first. So generally when you have we like to say that robots do three things. They sense, and then they think about what they've seen, and then they act on it. So you have sensors, and then you have actuators, and you have some sort of control in between. Where all of these AI models come in is sort of in between, in that thinking stage. And what's cool about ROS is that we've already handled a lot of the data collection and a lot of the data distribution things, so people can actually focus on doing the model building and the deep learning work that they'd really like to do. On top of that, once you have all this ROS data coming back and forth, we also will have capabilities for you to do simulation of your robotics application, which tends to be fairly valuable in the space of robotics. Collecting robotics data, especially in the real world, is extremely expensive. So having the capability both to collect things every time you send the robot out in the real world and then build a simulation that mirrors that is quite powerful. And all of this sort of tools and data collection formats that we've already built basically form the backbone for doing a lot of robotics research. So unlike some of the other, companies and organizations that are out there claiming to be open, we're actually headed in the other direction now. We're actually trying to make our organization more inclusive and even more open. So starting about 2 years ago, we actually pivoted how OSRA works to make it easier to bring in companies and individuals into our open source community and give them a seat at the table to make discussions about how we build the open source robotics of the future. Right now, our sort of strategic priorities are basically to figure out how all of this new AI works with all of our existing robotics capabilities, and how to build out the governance structure that allows us to build what the world needs when it needs it. So one of the first things we did, if you haven't heard, open source projects are dealing with a lot of AI contributions, is figure out precisely how AI is going to interact with the existing source code that we have out in the world. And we sort of went back and forth with the community and with some of our core contributors, and the policy that we sort of landed on is generative AI is fine, you can use it as much as you want, but you are individually responsible for the contributions that you make. And so going forward, you have to tell us that you've used AI to build a pull request, and then you also have to be responsive and generally not overwhelm our core reviewers and the process of getting that pull request merged. And this is a growing and sort of evolving process when it comes to an open source community. We've actually sort of expanded, the definition of or how we actually do this out in the open source world. So we've been getting, large batches of AI contributions from people trying out the latest models, and which is great. We're all for that, but we also need them to be responsive so that all those contributions also go through the same process that any contribution from any person or AI model would have. We've also been building a couple tools internally to help us just generally be prioritized and be more responsive to actual humans who need help and need pull requests merged ahead of some of the AI patches that may or may not have a high priority. But overall, I think it's been a net positive for the project. This is a pull request from my colleague Janos, who works at a company called Cellumation in Germany. He was just kind of noodling around with AI, was able to improve our serialization and deserialization algorithms in ROS by 2 or 3x. And it's really not a huge lift for him to come in and say, hey, I used AI, it did this, I checked it, it worked, we should actually approve it and merge it into the ROS core. So what's cool about ROS and the way we've sort of built it over the years is we've built it through well-defined interfaces and contracts. If you've used ROS before, you'll see that we have basically all the data that moves through a ROS system is based on a message data format, which is just a clear text description of the data types and their names inside that message. Also, basically all API calls inside of ROS use that same format where it's a clear text message. And what's great about all of this is that it allows agents and LLMs to quickly slurp up a ROS system and see precisely everything that's going on in that system and how to interact with it. So one example of this is I have some colleagues at Convergence Robotics who've sort of noticed this very early on, and they said, oh, what if we put an MCP server on top of all of this, slurp up all of the API calls inside of this robotic system, and then let your LLM of choice actually go crazy with it. So you can have a conversation with an LLM, and then the LLM can go make your robot do things. And this was not a super heavy lift. And you can kind of see there's a short video down there on the bottom right. You can have a conversation with an agent and have it control your robotic dog. What's really interesting about this is I was actually kind of skeptical of this early on, because some of these robots can be extremely dangerous, especially out in the manufacturing context. But actually, after having a conversation with the person who built this, they sort of mentioned, well, what's interesting about this approach is that you can use the MCP server to gate sort of dangerous tasks. And so you can let unskilled users actually work with the robot, but also give them some guide rails to prevent them from doing anything dangerous. Similarly, our colleagues at Robotech, I believe they have a booth outside. They're based in Poland, I believe, in Central Europe. They've been basically building a robotic agent framework for deploying embodied AI over the course of the past 2 or 3 years now. They use it heavily in their deployments in Central Europe. And it's free and open source, and you are free to check it out, try the simulations, and build your model, and then actually deploy it in a real-world robot. Along those same lines, this is actually some breaking news from yesterday. We have an OSRA member named Roboto, and really what they're focused on is how do we make all that data that comes out of robotic systems searchable. If you've ever actually worked with a robot in the field, you learn that you log just about everything, which is great until you actually have to go back through those logs to find, say, a failure or something interesting, or to use that data to go build a new data set for downstream training. What they've been able to do is use an agent to go through all of that data, describe precisely what they're looking for, and then actually have it return the timestamp where those events occur. So we've really liked to improve the agent situation, and we think one of the best ways forward for this is actually making our open source documentation easier to use for both humans and robots. The OSRA just last year put in about $250,000 into improving our technical documentation, and part of that process is reframing our docs such that they actually have hooks that tell agents this is what's going on, this is where you look for the next step in this process. Structuring the content to be very, very repeatable such that it knows exactly every time it looks at a piece of ROS documentation, the key pieces are going to be in a very specific order. So if we kind of transition now into the things I think people commonly think about with like physical AI, let's talk about models in ROS. So one thing I hear fairly often across the way over there, you can see a room full of robots, is people will tend to say, well, you can either do physical AI or you can do ROS, and never the twain shall meet. And the reality is, no, actually you can do both at the same time, and you should be taking the things from each that you need to accomplish your goals. So for us, what we've been doing is building tools that allow you to interoperate robot data with ROS data back and forth in either direction so that you can train VLA models based on ROS data that you may already have or be able to collect with the system that's already at your disposal. We've also gone through and done full ROS tutorials and example code on how to use some of the robot VLA models inside of a ROS2 system. I mean, there's a lot of other examples of this. AMD's introduced a new LLM-driven NPU code generator, specifically tailored for ROS. And then we've also got a new special interest group. The response to this physical AI special interest group has been probably the best of any special interest group we've ever put together in ROS history. We've got dozens of individuals from dozens of fairly well-regarded robotics companies all coming together to figure out what the future of open source looks like for physical AI. Another big thing that we've done is just overall improve throughput and performance in terms of robotic systems as it relates to getting data into and out of your GPU. So back in late May, we released ROS2 Lyrical Luth, which is our latest LTS release. We release a new version of ROS every year, but on even years, we release a version that'll be supported for 5 years, which is Lyrical. What this new feature does is it creates a new internal buffer type to ROS that once you use this buffer type, if you're moving data into or out of a GPU, you encounter no copy operations along your path in ROS. So these copy operations actually take a whole lot of time and actually slow down your processing pipeline. And what's cool about this is we did it in a way that's hardware agnostic. So any vendor who builds graphics processing units can come in and actually improve performance for their system in ROS. Last thing I want to talk about here really quickly is we've also been doing a lot of work to make simulation interoperability a reality. What we've done is we've made a common ROS simulation interface. So no matter what sort of robot simulator you want to use to collect your data or train your model, they'll all work with ROS. And if you need to move from one simulator because it has a certain capability to another simulator because it has a certain capability, you can do that fairly fast or very quickly. And if you're interested in this, there's actually a video from ROSCON last year that you can take a look at that'll explain the whole process of how that works. So as I wrap up here, I want to spotlight one place we've been using this. So over at Intrinsic, we've been holding the AI for Industry Challenge. And what this is we wanted to tackle one realistic but difficult problem in sort of the manufacturing industry. So if you've ever, say, worked on a car or built your own computer from scratch, you know that getting cables to and from certain places, especially if you can't see precisely what you're doing, or if there's other things in the way, is an extremely difficult task. It's not a task that's really usually accomplished with robots right now. And so we wanted to see if we could actually start picking away at that problem. So what we did is we created a competition framework where users were able to use whatever simulator they felt comfortable with to actually simulate a sort of representative environment of inside of, I think this in particular is inside of a server cabinet. And then, once you've done that, you can go train your model using whatever framework you want. We ended up using basically LaRobot and ROS together to train either a diffusion policy, a pi0 policy, whatever, pick your poison, whatever you think is going to be able to solve this problem, you were able to go and build your solution. And so in terms of results, we are now wrapping up the second phase of this competition. Here's a couple screen caps from the first phase of this competition, and we have a number of teams that are capable of solving this problem in simulation. Once we get through the second phase of the competition, we'll actually start deploying these policies out in the real world. So I like to say right now that in terms of ROS and open source in robotics, that we've sort of gone through the whole arc of, first they laugh at you, and then they fight you, and then you win. I think we're on the win arc in terms of open source. We're here at an AMD event. AMD has asked us to be here because they see a deep and useful relationship with the open source community. A couple weeks ago, or probably about a year ago, I was at Automate, the big automation conference in Detroit, and FANUC, probably the second biggest manufacturing robot vendor in the world, announced that they are going to support their own ROS drivers. And subsequently, I think we've seen just about every other industrial robot manufacturer supporting ROS natively. And then last is Intrinsic. Intrinsic helped put together that competition and also supports a huge, multiple of the ROS core contributors to do their work. So if you're interested in learning more, most of what you need to know about ROS can be found on our documentation page. docs.ros.org has links to our discussion forum, our Zulip chat channel, ROSCON event page, all these sorts of things. If you'd like to come meet the people behind this project and see what other people are doing with it, we're holding ROSCON Global in Toronto in late September. We'd love to have you there. If you're looking to make a charitable donation, we'd love it for you to support the OSRF and its nonprofit and educational mission. And if you're a company or an individual who'd like to get more involved in building open source software for robotics and seeing it deployed out in the field, we'd love it if you join the Open Source Robotics Alliance.